The September 2015 Western Cape. Question 8. In the circuit represented below, voltmeter V1 reads 12 volts when the switch is open and 10.8 volts when the switch is closed. When the switch is open, no current flows in the external circuit. So the EMF should be equals to 12. The value of the EMF is registered on the voltmeter when there's no current flowing in the external circuit. And then when we close the switch, the voltage drops to 10.8. It means that now we do have current flowing in the external circuit, and that drop in the voltage is due to the internal resistance. 0.8 volts. The internal resistance of the battery R and the resistance of R4 are unknown. When the switch S is closed, the power dissipated in the R2 is 2 watts. The power there is equals to 2 watts. The voltmeters have a high resistance, and the resistance of the ammeter is so small that it can be disregarded. So they are telling us the voltmeters have a very high resistance. That means that no current will flow through the voltmeters, and then maximum current will flow in the ammeter because the resistance of the ammeter is so small. Okay, let's analyze the circuit. The longer terminal will be positive and the other side will be negative. The total current flows from the positive terminal of the battery. So this is I total. At that junction right there, even though that is a junction, no current will flow in this direction because we just said that the voltmeters have a very high resistance. So no current will flow in this direction. The total current will flow this way. And at that junction, the current will be divided. In this direction, we will have I1, and in that direction, we will have I2. R2 and R3 are connected in series, so they will have the same current, but the potential difference will be divided. So this. So it means that through R2 and R3, we still have I2 flowing. So at that junction, we will have I1 and I2 combining to form I total. The current through R1 must be the total current. And then the current will go back inside the battery. 8.1, 8.1.1. Calculate the reading on the ammeter. We said R2 and R3 are connected in series. So for resistors that are connected in series, they will have the same current. So it means that if we can find the current in either of the resistors, be it R2 or R3, then we would know what I2 is. So we'll use R2 because there we have the resistance as well as the power. So power is equals to the current squared multiplied by the resistance. The power is 2 and the resistance is 8. So the current should be equals to the square root of 2 over 8, which is 0.5 amperes. 8.1.2. The reading on voltmeter V2. Our circuit currently looks like this. I'm just going to focus on the parallel combination because that's where V2 is. I'm not going to draw the ammeter. I'm just focusing on the resistors. So this is R2, R3, and that's R4. So now we are going to combine R2 and R3 because they are in series. So this will be R series and that will be R4. So the series combination is in parallel with R4, and then the total resistance for the R series is 10 ohms. So now we have the resistance as well as the current that's flowing through there, so we can find the potential difference. So we have R should be equals to V over I. The resistance is 10. We don't know what the voltage is, but we do know that the current is 0.5. This means that V2 should be equals to 5.0 volts. 8.1.3. The current which flows throughout the battery. So that's the total current. Now, I want us to look at, we'll take it from that circuit right there that we have constructed. So we are going to add R1 as well. So we are going to have something that looks like this, R series, and then we have R4, and then we also have that R1. So we have R1, R4, and then okay. So we are going to combine the parallel combination so that it becomes in series with R1. So now if we combine the parallel combination, we are going to have something that looks like that. So this will be R parallel. We will combine R4 and R series, and then it will be in series with what? With R1. We already know the potential difference that flows across this whole thing. Well, that is measured across this whole thing. And that is what is 5.0 volts, because we said resistors in parallel have the same potential difference. We don't know the voltage here, but we do know that when we combine the voltage across the parallel combination, and that is registered in R1, we should have V external. V external is equals to V through R1 plus the V through the parallel what? Combination. V external is 10.8. V of R1 is what we are trying to find, and then that is 5.0. So V through R1 should be equals to 5.8 volts. So now we have the resistance as well as the potential difference. We can find the total current. I should be equals to V over resistance. The voltage is 5.8 and the resistance is 2.9. So that's a 2. So the total current is 2. Then 8.1.4. The internal resistance of the battery. Well, EMF is equals to V external plus I times resistance. The EMF is 12, V external is 10.8, and the current is 2. The internal resistance is what we are trying to find. I'm getting 0.60 ohms. And that's 8.2. R4 is replaced by a conducting wire, by a conductor with negligible resistance. How will this affect the power of R2? Write down increase, decrease, becomes 0 or remains constant, and give a reason for your answer. We are replacing R4 with a conductor of negligible resistance, so that's essentially a wire. The total current will flow in this direction. So current always flows in the path with less resistance. So it means that the total current will flow in this direction because we do have resistance in this section. So no current will flow in this direction. If there's no current flowing there, it means that the power is 0. So the power is 0, becomes 0. So in other words, R2 and R3 will be short circuit. So R2 and R3 short circuit.